So, human brains, we all have one, okay? They haven't changed very much for thousands of years, but their environment has. If you imagine where we evolved from, the world we live in now, is extremely, extremely different. So let's have a look a little bit back into history. Let's go back as far as 1970. Now, this is going to be a somewhat more interactive keynote than you're used to. I'm going to need some volunteers. I would like, please, someone who thinks they're quite smart, possibly a bit of a snappy dresser. I do have a tie for you to wear. Someone with a smart analytical brain. Please, may I have a volunteer? Come on, don't be shy. I'm not going to make you. It's like I'm not going to make you live code or anything, because the tools of 1970 for you. I have a tin of pencils here. This is your code, your design tool of 1970. Right? So I have for you a pencil. I have a sheet of blank paper, because this is what you need as an analyst in 1970. This is a tie I was given as a project memento in the 1980s, early 90s. So I have it because it was this or nothing, and I wasn't going to have nothing. Anyway, mild rant over. I also have a template for you. I have a flowchart template for you to draw your design. This is 1970, so this has to be a guy, because this isn't ladies, this is not a job for you. Yeah, go on. Come along then. Please come and be an analyst. Thank you. So please, and you do. Impeccably dressed. Yes, impeccably dressed. Need the tie for this job. Lovely. It looks better on you than it does on me. Right, there you go. So here's his tools of the trade for 1970. Right, so his job is an architectural one, a design one. He doesn't actually get his hands dirty with the code. So we need somebody with some confidence, please, to come and be a programmer, because you really need to think you're it to be a programmer. Don't worry, we will not see your code. Whoops, hang on, where's my clicker gone? Right, so there's Dom's kit. Right. Thank you very much, Dom. So Dom is our analyst. We need a programmer. So when Dom's done his job, the programmer will take that material, take that flowchart, and using this, this is an IBM System 370 set of instructions. So you've got that to help. You don't have to figure it out on your own. And a coding sheet. And you too get a pencil and a tie. So, is anyone in here a programmer? Right. Thank you, Roger. So if you'd like to go and sit in the office next to Dom.
Yep.
Oh, there you go. Hang on, I'll get you one pencil. You only have one pencil. You can't have the entire tin. Right. Ladies, I hope you're not worrying that there's no job for you in 1970. Of course there's a job for you in 1970. It's typing. So, when Roger has done his clever stuff on his coding sheet, your job will be to take that coding sheet and type instructions basically type into a machine, so that code gets converted into a set of punch cards. This was actually my sister's first job from school, punch card operator. She later went on to be a programmer. Go Jill. Right. So I need a lady volunteer, please. This is not for you chaps. I have a job for a lady. I have a pretty scarf for you to wear. We're not so short of ladies that I can't find a lady volunteer. Yeah, come on, there must be a lady. Ida. For a duck, Ida. Thank you very much. So, there you go. So your job, once you're dressed for it, is to produce these. Let's go. Oops, hang on, too many. So there's the punch cards for Ida to produce. Right, somebody with a beard, really. That's my only criterion. Ladies or gents. Anyone with a beard. Lovely, thank you very much. Now you, there, and you can stay there actually, because you can stay in your enclave. Thank you very much. What's your name? Patrick. Thank you, Patrick. So Patrick is our machine operator. He lives in the machine room, which is separate from all this. No, none shall pass here. Right, this is, because once Dom has done his analyst job, he will pass on his flowchart to Roger, marvellous, who will fill in his coding sheet according to the instructions on the book. So the coding sheet hands on to Ida. Ida sits there and types. Ida will probably find this so mind-numbingly dull that she will end up just sort of seeing how fast she can get at it and racing with her friend at the next desk. And also will get a bonus for being more accurate. So, because there's a sort of double-checking thing to make sure that the things are typed in correctly before they go. Right, so we will, Ida, once you've got those cards punched, you can bring them down the hall and put them through the hatch, but you may not enter. Pass them through the hatch to the machine operator, who is in charge of this beautiful thing, this very expensive machine. So you may hand them, once you've done the cards, you can hand them over to Patrick, through the slot, lovely. And Patrick, who rules like a kind of benevolent troll in a dungeon, will drop these into the machine. The machine will process these cards, and some output will come out from it on paper printout, or maybe onto another deck of cards, but quite often print out if it's for payroll, things like that. So back in these days, the very idea of you owning a computer is ridiculous. Not even companies necessarily owned the computers. These were big, expensive things, and in fact were leased by some companies. So, very, very different times to what we have now. So, I would like to pay, I should pay you less really, but I'm not going to, it being 1970. So, there's your pay. Thank you very much, Dom. And you see, I have my ducks in a row here. Well, you probably can't see them because they're tiny, but very nice to have my ducks in a row. Thank you very much, Roger, for your sterling service for the company. Unfortunately, time has moved on. And happy birthday to you. Happy birthday to you. You know too. Thank you. And finally, thank you very much, Patrick, for dropping those into the machine so beautifully. So this is the pipeline. Oh, so thank you very much. Round of applause for these lovely people. Thank you. I didn't. We'll code review Dom's code later. Right. Okay, so that's the pipeline, 1970s style. So actually, not a vast amount of communication needed. Fairly simple system. It would tend to be something within the company, bespoke for them, not for a general audience. It'll be doing the company's stock control, the company's payroll, whatever things needed within the company. So my sister's husband was an analyst programmer working on payroll and stock control for a compressor company. So shout out to Ian as well. Hello. We're at it there. Right, so we move on to 2023. Right, we've been looking at thousands of years of human history and the brain not changing very much. But actually, so clearly it's not changed much between 1970 and 2023. But the environment has changed a lot. So the pipeline of 2023 looks more like this. And amongst the things you'll notice on this, it's an altogether more complex pipeline. Lots more toing and froing, lots more people involved, a lot of communication. Where are we? We've got escalate to the director. We've got, a 50-person conference call. It's quite clear in this one that you need to communicate with other people, which makes sense. No one person can be building a big system like that. You need multiple people working together synchronously on this, putting some code in all the way through to getting a delivery out the door at the other end. So a very different proposition. So I hope this gives you some hint that communication and understanding other humans is kind of important. So we've got complex systems more than one single person can do. And we've got essentially two dimensions. I mean, putting them in two dimensions is a bit of a simplification, but there's the computering skills, being able to make the computer do something, putting in some instructions, having the right result come out. And basically any idiot can do that at some level. Right? Some people can do it better and more easily than others, and some people get paid for it and some won't. But that's one skill. And some people are really good at it. That person over on the left there, for example, really good at the technical skills, can make the computer do their whim with ease and make it do beautiful things. The other dimension I've got along there is the humaning one. This is my preferred phrase. Soft skills is just kind of too wet. It's not, it downplays it. It's not the right term. And I think I may have done a lightning talk about this at one point, having asked for a better version. So I'm characterizing it as computering and humaning. So where are we? Top left dot, really, really good at computering, not going to thrive in a complex environment where people need to communicate. On the other hand, bottom left dot, no good on the tech and no good on the humaning. We probably don't want them on the team. But then what about the others? How about that one, the third one across from the left? So a bit of humaning skills and a bit of tech skills. So definitely more humaning skills than the one on the top left. Depending on your circumstances and what you're doing, maybe they'd be better. As a very smart friend said, I'd rather hire someone who's got those communication skills, those people skills, and train them to do the tech stuff than have somebody who thinks they're all out on the tech, because training them in the humaning skills is kind of difficult. And then over on the right-hand side, we've got people with really great humaning skills. If you've got the great humaning skills and the great tech skills, well, that's the holy grail. But it's actually a relatively rare combination, but we can move more towards it from either direction. So I'd probably prefer that one over the lower one down. But personally, I'd take the person with the good humaning skills over the person with the massive tech skills, because they're not somebody working on their own in isolation in a dungeon. Despite all the stereotypes of hoodie in a basement, it's just not like that. So, a couple of people have said recently in talks that the code is not important. And they're absolutely right, but it needs a caveat. The code is not important to end users. It is important to fellow developers. They're an audience too, a very different audience. They're not an audience for the features, they're an audience for the source code. So it really does matter. There are various stats about how much code gets read rather than written, and how much time is spent on that. Basically, think about your life, how much time you spend reading code versus how much time you spend typing. Remember that other devs are an audience for it. And those devs, that audience for it, are humans as well, right? With human brains. Human brains have definitely not followed Moore's law, RIP Golden Moore, who died in March. So we're still the same kind of ape brain that we had, thousands of years ago. And there's no great evolutionary pressure for that to change, even though our modern environment is very strange and very different. Basically, we apes are too smart for our own good, so we can survive these things despite the fact that we've evolved in a context of, hunting, gathering, finding shelter, that kind of thing. That we cope pretty well, actually, considering in our modern environment, because we've got those cognitive skills. So, cognitive psychology, let's turn to some of the psychological theory a bit. Let's try to use some information processing models to explain how those brains behave, as it happens in the modern world, but just understanding how that brain operates. And this can be a useful model for understanding some of what we do, but all models are imperfect, right? They must be, because if you modeled it to absolute perfection, it would just be the thing, and there'd be no point in having a model. It's a simplification that helps you, it's a useful model if it helps you understand some relevant aspect. So this model, it's a model of memory. You've got the sensory input, so input, simple enough to understand. There's some very short-term memory, quite large, but things sort of disappear from there quite quickly. It's quite sort of leaky of all the senses coming in. And then that gets processed through short-term memory, we've got the loop on there, you've got the rehearsal loop, sort of rehearsing it through there until eventually it can get transferred into long-term storage. So maybe it's in RAM and then it goes to disk or something like that broadly. So, imperfect model, because humans are not computers. They're actually in the brain's about 1.4 kilos of jelly, basically, with a lot of neurons. So pretty amazing capability, really, for 1.4 kilos of jelly. Really versatile, able to do a range of tasks, cope with an awful lot of things at different levels. It's really quite impressive for a bit of sort of organic material. But it does need shortcuts to do that. It can't cope with all the information and process all the details. Some bits have to be let go. So its failure mode is very different to a computer. So a computer might slow down with processing through stuff, but unless you fall off the end of a buffer, it's not going to lose stuff. It's going to go slower, but it's not going to start taking shortcuts and coming up with wrong answers, unless it's ChatGPT, of course, in which case it can invent whatever it likes at random, as far as I can see. So ChatGPT, in some respects, is remarkably human in the way it gets things wrong. So let's look at what the brain can and can't do, and how it makes the best use of that limited capacity. Remember, just like 1.4 kilos, that's quite impressive, what we can manage to do. But some of what it does in coping with those limitations makes it look like there's some irrational behaviour or mistakes. But please don't think of that as a weakness. If you're working in security, don't say that humans are the weakest link, or I'll come and slap you as far as is possible within the terms of the code of conduct, which probably isn't at all. But so it's not a weakness. The human brain is evidence of what is often essential optimization to be able to function with 1.4 kilos of jelly in a really complicated world. So if we're optimizing for limited resources, there are always compromises in that. We're no different in that respect. But I guess we're the ultimate case of premature optimization, really. So that's what we've got. We've got 1.4 kilos of jelly. So our perception, we think of perception, we perceive the world around us with this brain. We've got that input from sensors, but it's not, the model breaks down a bit there because we can't pay attention to all of that. We're not using all that sensory input. There's just too much of it to deal with. So you imagine if you look at the carpet closely, you can see sort of individual fibres in the carpet. If you look around the room, there are lots of details to look at. There's, every letter on the screen, different parts of the room. You can't take it all in at once. I mean, it's way too much. How can you make sense of it? Look at everyone's face, remember everyone's face? Not a hope. So we have to be selective about it. What we actually perceive is selected by attention, and then at that point, the brain's getting involved. It's not just a direct sensor wired into somewhere as here as the input. This is the truth. Experience interprets it as well. The sense you make of it is affected by your past experience, your knowledge, even your mood. So let's experiment. Let's have a look at how the brain gets involved in perception. Let's demonstrate that it's not just an accurate input that's a complete representation of the real world. So, hope you'll find around the room several of these. So, if you keep both eyes open, holding the tube in one hand, hold it to your eye, put the other hand close to the tube, and if you're not seeing anything weird, move your hand to and fro slowly until you find the spot where you experience the illusion. Anyone got an effect? So hand right up against the tube, both eyes open, and look ahead into the distance. Anyone got a hole in their hand? Yep. So is there a hole in your hand? No. Anyone waiting for a tube to play with? Shall I throw that? I don't need that one now. Whoops. Right. So it's not just an input. Right? There's processing that happens to it. So hand against the tube. Hand against the tube, Felix. Did you see it? It's freaky. Quite freaky. That's human brains for you, right? Because we've got input from both eyes. We're perceiving that as a single image in the brain. It's doing it's pretty smart processing, actually, combining that into one binocular image. That's quite impressive. But it can't always, sometimes we can trick it. All sorts of optical illusions can trick it. So it's important what we attend to. So at this point, let's play you a video.
Hi, I'm Richard, this is Sarah, and we're going to perform the amazing colour-changing card trick with this blue-backed deck of cards. Now the idea is very simple. I'm just going to spread the cards in front of Sarah and ask her to push any card towards the camera.
Right, okay, let's see. I'm going to go for this card here.
Okay. Now Sarah could have selected any card at all from the deck, but she selected the card which is now face down on the table. And what I'm going to ask her to do is show us which card she selected.
Right, so the card that I chose was in fact the 3 of diamonds.
The 3 of diamonds, okay, an excellent choice. That card goes back into the deck. Now I'm just going to spread the cards face up on the table, do a little click of the fingers, and you'll see that Sarah's card here has now got a blue back. Not particularly surprising. What's slightly more surprising is all of the other cards have got red backs. And that is the amazing colour-changing card trick. Hi, I'm Richard, this is Sarah, and we're going to perform the amazing colour-changing card trick with this blue-backed deck of cards. Now the idea is very simple. I'm just going to spread the cards in front of Sarah and ask her to push any card towards the camera.
Right, okay, let's see. I'm going to go for this card here.
Okay. Now Sarah could have selected any card at all from the deck, but she selected the card which is now face down on the table. And what I'm going to ask her to do is show us which card she selected.
Right, so the card that I chose was in fact the 3 of diamonds.
The 3 of diamonds, okay, an excellent choice. That card goes back into the deck. Now I'm just going to spread the cards face up on the table, do a little click of the fingers, and you'll see that Sarah's card here has now got a blue back. Not particularly surprising. What's slightly more surprising is all of the other cards have got red backs. And that is the amazing colour-changing card trick.
So, fabulous video. I don't know how many of you spotted things on the way through. Anyone spot all of them? Anyone spot any of them? Okay, cool. So there's a lot going on in there, right? Oops, I didn't mean that to go on there. So this isn't a failing, right? This is limited capacity attending to what's salient. So it's a really useful coding skill. You want to home in on the salient things and not be looking at all the fluff around the edges, all the irrelevant stuff. We're not all identical in this. Also, that's sometimes what you choose to attend to in debugging can be driven by your preconceptions about what's in there, and you can go off down a rabbit hole looking at the wrong stuff. You're paying your attention to the wrong place. But generally, if it's well directed, it's a really useful thing to limit your attention to a particular aspect and not be put off by all the other stuff. So, like I say, we're not all identical. Social science is all about probabilities. So there's a lot of sniffishness about whether or not it's a science. But it's not a natural science, of course not, because you can't have a consistent sample at standard temperature and pressure of a human. But what we do have is a rigorous process for measuring the probabilities. So it's a different thing. Social science is not natural science, for sure, but it doesn't mean it doesn't have its own scientific rigour in doing that. Let's get that one out of the way. So we're not all the same. There are probabilities. Also neurodiversity, just the general differences, but also neurodiversity is a big one in this. There's something I'm going to show you shortly that a student with autism did live in front of a big room of students and did amazingly with in a way that nobody else, I don't think, would have managed it. I'll tell you when we get there. So that's quite handy, seeing the things that other people don't do and noticing things and asking those other tangential questions, and particularly in something like cybersecurity, for example, where you want somebody to... It's all very easy to consider the nice, happy use cases of all things working nicely. How about the abuse cases where people can take advantage of what you've done to get into the site? Being able to think around it and consider all those things from different angles is great. So, we don't always see what we're looking for. You might miss errors that you've read, and you know what it's like if you're reading your own stuff and you've read. I stop at about 3. If I've looked through it 3 times and I'm not seeing it, I'm not going to see it, right? It's you don't know what's salient, and it's much easier sometimes to see what's salient when you explain it to somebody else or when they look at it for you. So let's get past. There we go. Thank you. Right. So some practical implications for this. We can't pay attention to everything all at one time. I think what Alistair Cockburn says about information radiators is kind of relevant here. You can't be paying attention to every little detail that's hidden away on a system. For example, on a wiki. You need to remember to go and look for a start, and you're not paying attention to it. If you've got something up on a wall, somewhere where you can see it, a screen that's changing, displaying your status, whether it's paper and it's post-it notes, or it's a big screen displaying some kind of status, or a whiteboard doing that, something out there where you can see it, radiating the information at you, drawing your attention to it, is way superior for some things to having it hidden away on a computer system. It occurred to me after Roger's lightning talk yesterday as well, that if you had wiki pages maybe just scrolling by on a screen, people would notice the out-of-date bits and go, oh, I better go back and fix that or delete that. It being tucked away, it's, write once, forget forever sort of stuff. If you're seeing it coming by, that can make a difference. So yeah, don't bury stuff in a wiki. And also, if it's buried away somewhere on a computer system, you have to remember to go and look. And some things you'll remember to do and some things you won't, which is almost a segue into talking about memory. So, something that's very much studied, often in labs with artificial tasks, so not the greatest ecological validity always, but with some useful findings nonetheless. It's about those models. Do they tell us something? And yes, they do with memory. So a tendency to remember recent things and maybe the first thing. So, for example, with a conference, you might remember the first talk you went to, you'll remember the last talk you went to, and then you'll remember the ones that spoke to you, or the ones that really annoyed you, indeed. It's about, affect, how you feel about it, an emotional response to it. Those will be the ones you remember. So, on the subject of memory, though not particularly an issue here, false memory is always a distinct possibility. We're not designed as well to cite sources. So if somebody tells you something, I don't know, maybe they talk to you about a presentation that they went to some years ago, and they describe it so clearly that you can take it in, almost to the point when you look back on it, you can't remember whether you were there and you're remembering for yourself, or whether you're remembering what they told you. Because we remember the information, the things that interest us, the things that are salient, the things that we pay attention to. And that's not, for example, that, so-and-so told me about this great talk they went to. You just remember the information about the great talk. So we're not good at citing our sources, which is in terms of how we store stuff in memory, which is mildly frustrating to me as an academic. But it really annoys me when I can't say, someone's told me something, I can't remember who it was. I have to say, somebody told me this, it wasn't my idea, but sorry, I don't actually know who it was. But it's normal and it's human, so I should cut myself more slack. So I said I'd talk about models of memory a bit. This is breaking down the model that we saw earlier, just into some more details for different sensory modalities. So rather than being one lump that says working memory, it breaks it down into phonological loop for the things you hear, and visuospatial scratchpad for the things that you see. So, of course, that's not a perfect model of what happens, but it has some uses. And it's relevant to us, I think, because there's only so much you can be processing at one time. This is one of our limits. So, what experiments find is a working memory capacity of about 7 elements, plus or minus 2. So if you're doing that with digits, like a digit span, or so someone reads out some numbers like 73521, how long a span can you repeat? Up to, and the average is about 7. Yeah, like I say, plus or minus 2. On a good day, I actually have a digit span of 9. This is no great claim to great memory, as you'll see in a minute. This is the one that I'm doing this live, doing a digit span thing online, that my student could stand there. Imagine standing here trying to, I can't even remember the digits I just told you, for goodness sake. But he was just doing a perfect job on that, and basically until I interrupted him. It was extraordinary. That focus is impressive. So, and useful. So that's digits, that's a verbal thing, remembering those in, it would work the same for me for letters. This one, though, this is an illustration of Corsi blocks. This is a visuospatial one. So with this one, the experimenter or the computer, whatever, points to these in a particular order, and then you have to repeat that order. I am spectacularly bad at that one. Spectacularly bad. To the point, it's really quite stressful. I'm so bad because I can do so few of them. And it's not dissimilar to, remember that Simon game where you had to remember a sequence of things? Yeah, the lights that light up and you press the buttons in the same order. I never had one of those, and it's probably just as well because it wouldn't have been a great present for me. Absolutely rubbish at this. So we've got those different senses coming in, and we vary in how well we process different ones of those. And also, another thing I'm quite bad at is faces. So if I appear not to recognise you, please don't take it personally. It takes a long time for me to recognise faces. There are some people who can't do it at all. It's called prosopagnosia, and they literally cannot recognise people's faces. They depend on other cues, like, glasses or a sort of particular piece of jewellery that they always wear. So I'm not quite that bad, but I'm pretty rubbish at faces. So, practical implication for this: make smaller changes. Right? There's only so much we can hold in our brain at one time to actually do some processing with it. So I've stolen this from a recent presentation of Jez Higgins, but it's not the only person you'll have heard it from. You'll have heard it many times. But it makes psychological sense to do that. So it helps for things you do for yourself. It also helps for somebody, for example, doing code review. We had some talks yesterday about just the amount of stuff you put in one time into a code review, the bottlenecks that can cause. Can't remember which talk that was. Sorry, whoever it was. See, humans rubbish at citing sources. So there's only so much you can reason about in one headful. So make life easier for yourself by not doing too big a chunk at one time. So I talked earlier about attention. You saw how attention mattered in the colour-changing card trick. If you do manage to get your attention onto something, and you've got a real state of absorbed focus, have anyone had that? Yeah, nice feeling, right? It's a lovely feeling. I got it once. Somebody asked me about actually why, with my box of questions, why do people forget to sort of sleep and eat? I've never forgotten to eat for too long, to be honest. But one job I had, I was lucky enough to have a 2-person office. My office mate was away on holiday. I was sat there working quietly through the morning. I finally realised I hadn't had lunch at 2 p.m., which is a good 2 hours too late for my usual, it must be time for lunch alarm. So just it was the perfect environment, no interruptions, completely absorbed in what I was doing, getting things done, making progress. So that getting things done, I think, is very rewarding. So my suggestion to the person who says, why do people forget to sleep and eat, is maybe it's those little dopamine rewards of the progress you get as you do it that keeps you going on. Maybe it's a similar thing, I guess, to what keeps you going on a game, to get that next little reward, and you achieve something, and that's very rewarding. It's not dissimilar to addiction. I'm not suggesting that if you reach a flow state, you're addicted to programming, but it's there are relationships in the brain chemistry there. So that's a flow state. If you want to know more about flow, this book is the one to read, including details about how it's been studied, because obviously you can't sort of stick some electrodes in someone's brain to figure this. Well, I say obviously. We do have ethical standards, and you're sticking electrodes in someone's brain for that. Well, I don't think you'd get a flow state, actually, with electrodes in your brain, probably, would you? So, Mihai Csikszentmihalyi, I think. If anyone like to correct me, who has better understanding of the language? I've practiced that one. I can't say the Icelandic volcano, though. So, here's an information processing model again, probably one you're fairly familiar with, I would think. Processing going on, interrupt happens, and you resume. So, is this a good information processing model for humans, for interrupts to flow? I see some shaking heads. Is this better? Yeah, so once attention on your task is broken, we can't just reload it, we can't restore it from memory. Suddenly all those other things, we haven't got a scheduler going, no, all those little worries about domestic tasks and the other thing you've got to worry about, and got to do this and got to do that. It's not keeping those out of the way for you. Those all come flooding in going, me. And it's very hard once it's interrupted to get that state back for most people. Some may manage it, but for me, it doesn't take much, to be honest, to break it. So if you want flow, if you want to have a chance of reaching a state of something like flow, maybe you don't want notifications popping up, because that's going to break the spell. And there are individual differences in how people concentrate, so notice what breaks yours and consider, is there something you can do that would actually mitigate that? Maybe, and what's right for your colleagues as well. Maybe you need some to differentiate between regular interrupts, which you may just aren't, you're not even going to do in some circumstances, and non-maskable interrupts like, the building is burning down, or production server has just collapsed. There's some things that do need your immediate attention, others don't. And that, I can't tell you a single size solution for that, but what you might want to do is discuss things locally and find some way that works for you with the individuals in the team. So, I've talked a bit about memory, the constraints of that. They're measurable to a degree. We can do those. The ecological validity, how much they really match real life, is a bit doubtful, but they do give us some things we can measure about primacy, recency, and emotional response to things that do reflect everyday behaviour. The other constraints we have, among them, are just what we can reason about. How much data, we've got issues with how much data we can take in, how much of it we can process at a time, how much attention we can pay to it. We have constraints there that our 1.4 kilos of jelly do a pretty amazing job with. But there are some shortcuts we take to get there, to make that happen, make that work. And they're a bit harder to measure in a quantitative way, but they do have observable patterns. So this is the book on that subject, Daniel Kahneman, Thinking Fast and Slow. Basically, we get by with our 1.4 kilos of jelly because we optimize with some fast thinking. And for our former life, hunting, gathering, building shelter, it works pretty well, actually, on dodging predators. If you see a tiger and you respond quickly like that, you're probably the one who's going to survive to reproduce, compared to the one who goes, oh, well, let's see, that has this many stripes and it's this colour, and okay, it's coming towards me at approximately however many miles an hour, and oh dear. So quick responses are important, useful to us. So this book, incidentally, my copy of this book came from a bookstall here So I'll use this as an opportunity to plug Jim's bookstall. It's amazing. You can pick up some really good books. This one I bought has a load of underlining in, so I also know what the previous owner thought was important in it. It also peters out through the book. Lots of highlighting at the beginning, less at the end. So we reached some quick conclusions. We have a limit on the time we can spend processing things. We do it in a reasonable time rather than complete accuracy for some definition of rationality. But for full rationality anyway, you're going to need all the data. And we don't have all the data, because as we've said, we can't take it all in, we can't hold it on our head. We can't know every single factor. It's like, okay, judging the colour of the carpet by every single fibre, can't do it. Take an overview, kind of red. Okay, so this is really, really good. This is amazing, clever stuff that we can do this to use our limited capacity as a human to optimise and make good use of the jelly we've got. So, this does have some consequences. Let's have a look at a few questions that have been tested in. So, like I say, these things do get experimented and observable in a slightly different way. So, which of these causes more deaths? Hands up for disease. Okay. And hands up for accident. So, slightly more for disease. You're a smart lot. So, disease is about 18 times as much as accident. The font sizes here reflect the difference. In the experiments that are done on this, so you're not a representative sample for sure, and also you're in the context of a talk about psychology, so you can, what's the trick here, what's the trick? But yeah, in the experiments on this, people's responses put them about equal. It's quite a lot different to 18 times for disease, right? Let's try another one. So, lightning. How many for lightning? Okay, and for botulism? Okay, so overwhelmingly in favour of, well, not in favour of botulism. Overwhelming vote for botulism being more deadly than lightning. Okay, lightning, 52 times as common a cause of death as botulism. And yeah, the results consistent with just lightning was reported as being less likely than botulism. You really are consistent with the samples used in this study for that one. Okay. Accident or diabetes? So, accident. Okay. And diabetes. Well-informed lot. Diabetes 4 times as much as common as accident. The actual result from this study, 300 times more likely, people said, accident. 300 times versus diabetes. But yeah, and that one, there's probably an amount of sources of other information, right? So these are all examples that illustrate the availability heuristic. It's about things you've heard about, media coverage. I mean, that's a limited source of data. Where have you got your information? What gets reported? So it's not a blaming of the media here, but where have you got your information from? So you lot are obviously well informed about diabetes. Whereas the population tested here weren't. So what you hear about on the news is accidents, right? And plane crashes are another good example of this one. People think that's much more likely than it actually is, because when one happens, it's actually fairly rare. So when it happens, you hear about it, right? News doesn't report every single car accident, because they're just way too common. There can usually be nothing but car accidents. So we work with the data we have. If you've got limited data, it's not going to be an accurate answer. I think that one probably is fairly obvious. I'm going to say obviously for that one. So another bias, having built it yourself, which kind of seems relevant to me for software development. So the IKEA effect. Valuing a piece of furniture more, rather disproportionately, if you built it yourself. It's a specific example of a more general thing of an overall bias whose name I forget for the moment. So I'm sure you've seen that with code, with other people with their code, or maybe even with your own. Yeah, I'm really quite pleased with that, and it's not, and nobody else is actually sharing your enthusiasm for how marvelous it is. So this has implications, right? If you feel that ownership and that pride in it, you're not going to want to let it go. So I've stolen some advice from writers here, and there are various versions of this, various attributions, but I particularly like this one from Stephen King because it's, well, A, because I could actually find a fairly confident source for this to know that this version was Stephen King's, but also because it covers the egocentric bit. Kill your darlings, even when it breaks your egocentric little scribbler's heart. Kill your darlings. It's hard, it is hard to do these things, but sometimes they have to go for the greater good. So this, the egocentric bit, I particularly liked because it relates back to this book, which has been around for a long, long time now, and where egoless programming was proposed. So shared code ownership needs some attention. It doesn't just happen by accident. Some people pick up a task to do, they go do it. An individual has to, well, maybe you've done it pair, maybe you've done it mob, so it's not just an individual, but somebody has taken the lead on doing that. And it takes some effort to make sure that that code does belong to everybody. Arbitrary deadlines don't help. Right? If you've got a person who wrote the code, they are the expert in it, the quickest, most expedient thing to do often is to have them make the change. And then the next time around, they're even more expert in it, so it's even more expedient to have them make the change. So there are external time pressures on that make it hard to do this. But it's really, really important, not least so that you don't have a terrible truck number where if that one person, or lottery number, let's be more positive, the lottery number, that one person wins a massive lottery win and never turns up in the office again, and you're left with their code. Yeah, so good luck with it if it's just that one person. So, there's lots to say, don't let it happen, that code becomes one person's sort of pet project, but human psychology is in the way there. We have to work with it, recognize it, and not ignore it, because otherwise this will just happen by accident. So, speaking of when to get rid of things, another shortcut that the brain takes is sunk cost fallacy. So, that attachment means, this is related to kill your darlings, really, hanging on to it rather than throwing it away. Flogging a dead horse, essentially. As Roger, I can't remember when you said it, but you said the other day that it's sometimes quicker to throw something away than it is to try and debug messed up logic. But if you're too attached to that messed up logic, you're going to keep trying to coax it into doing the right things. You need to know when to get rid of it. It's back to attention. You need to pay attention to the warning signs that you get that something's amiss. And you also need to listen to the Cassandra in your group who is saying, doom, gloom, things will all go terribly wrong. Cassandra, sadly, was doomed never to be heard. Please don't let mixing my metaphors horribly, don't let the canary in your mind be ignored. So yeah, don't call your canary Cassandra, I guess, is the advice from that one. So I'll return a little bit to, yes, so I'll return to Cassandra's a little later as well. So this is a slide, quote from Aldous Huxley, stolen absolutely shamelessly from Kevlin Henley's slides because it's just spot on. This ties in very closely with that whole graph of fixing defects and it being cheaper to do it to the left. Spotting the signs, knowing that you're on a bad course and correcting it rather than plowing on regardless with that sunk cost fallacy can save you a fortune. So, I think the last one in this section, not quite. So, it's really important to be honest with yourself and each other about the idea, great ideas. Fabulous idea. Oh, there's this thing we can use. This new framework is fabulous. Bear in mind it has consequences, right? So you might be getting some velocity increase from it. Great. But that's only part of the story. The overall cost of doing something different, adding something in, is increased by the maintenance burden, those changes from what everyone currently knows and is familiar with and fast and capable with. There's a maintenance burden that you need to set against the velocity increase. And that's not really a decision for an individual either. So it's just something to bear in mind. Do I have time to tell you an example? Yes. So this is the guy I think of as Dave, but I thought I ought to check what his actual surname is. And given that I'm ranting about it, I particularly love that his surname is genuinely Rant. Well, I'd say it's genuinely Rant. Somebody told me it was Rant. Of course, they could have been winding me up. Anyway, some really pathological examples of this. Kind of trivial ones. They're not a massive implication for the code base as a whole. But I once worked with someone, let's call him John Smith, because I'm going to put two examples in here. If I gave his first name, he'd be identifiable, and that might be a bit embarrassing. So we had a wiki. Back in the days when wikis were a new and shiny and exciting thing, we had a project wiki, and we were running along quite merrily on this thing. We'd all learnt to use this whizzy new tool, and it was actually working quite well for our project because it wasn't a long enough time scale for it to have totally stuffed up yet. So we were doing that, we were fine. And then one morning, John Smith spent the entire morning moving all the content over to a different wiki platform because it was new and better. So he wasted, and bear in mind, we had no problem. What problem are you trying to solve? There wasn't one, except that, I nearly said his real name, that John thought this was a great idea. So an entire morning of an expensive engineer's time wasted doing this unnecessary step. But not only that, all of us who knew how to use the existing one then found everything had changed. And yeah, not a massive effort to figure it out, but a really unnecessary bump in the road that meant we all had to go learn how to use this new one. I can't remember which either of them were. I can remember both of them, but I can't remember which order they were. This same person had form. This person, before I joined the company, had found this folding editor, which was a new thing at the time. Right? I'm folding stuff now, sort of, bog standard, normal. You can view an outline. Confuses the hell out of me. I can't get used to it. I'm just I'm an old dog, and that's a new trick. I can't do that one. But because I forget that things are there. See, how much can I hold in my memory? And maybe paying attention to less of it would be good, but then I forget what's in there, so it doesn't work for me. But anyway, this folding editor that John had discovered required markup in the file. So he put markup in the file, and he committed the files with the markup in it. So that markup was there in the way for everyone else not using this folding editor. I mean, yeah, I'm very tempted to name him. But anyway, yeah, massive, unnecessary, that one's worse, actually. Again, not affecting the system, but slowing down. Look at the velocity increase for him, maybe, and velocity decrease for everyone else. Anyway, rant about John over. Let's move on before I actually name him. So, as I mentioned earlier, user doesn't care about the code, right? They're not interested in the code. But your peers do. So if you're pursuing your own personal vision of perfect, that doesn't necessarily mean it's what they need to see. This is a community effort. It's not your code. So this vision of perfection, this includes code review, right? If you're being unnecessarily pernickety about something that really doesn't matter, and you've got your own personal concern about it. So somebody mentioned to me in the question cards about a massive obsession with vertical alignment. So who knows, maybe this person in the code review would be a bottleneck because they're saying, oh no, it needs to be like this. So I have no idea how they talk. They probably don't talk like that, but it needs to be this way because this is the one true perfect way to do it. So yeah, they need to consider that that's really not worth it, right? The cost of that it's not their code. So I've been really quite rude about, oh God, yeah, one last time, really quite rude about John, and silly voices about someone's poor colleague, but actually there is psychology around the whole attribution of of characteristics to other people and sort of assessing what you think they're doing. So, one of the things, one of the places where this comes up is in the sense of personal versus team priorities. It's one of the things that can be a source of tension and an absolute source of blame. You can see it. Gosh, it's how many years since? Oh my goodness, it's like well over a decade since that, but I'm still quite capable of ranting about it at length and need to be stopped, really. So, fundamental attribution error, absolutely common human thing. So, when you're on the outside, looking in, you're much more inclined to see things as personality traits of the individual in their behaviour. So it's very easy for me to say that John was an idiot who didn't care about the rest of his team. What I don't know is how things looked on for him on the inside. And it's different being on the inside. You haven't got that view in. You're looking out at the context, and you know that this is going on, and that's going on, and this might be useful, and that might be useful from your perspective, and you're seeing a whole context around you, whereas somebody observing what you're doing is focusing more on you. So this is one of the possible explanations for fundamental attribution error. So you don't have all the information, right? I mean, I'm not going to excuse John, but it's in other cases, the reasons people do things might actually make sense if you, or for some reason, if you ask them about it. Don't just assume that they're sort of trampling over your ideas and doing things their own sweet way just because. You don't have all the information. If you ask them about it, you can discuss it, and you might learn that actually, oh yeah, that's a good idea, I agree, now I understand. Or it might be an opportunity for them to socialise that idea and share it and go, is this good for us or not? And actually you might help them realise. So don't just blame them. That's not like I was blaming John. That doesn't really help. Well, I still blame him. I'm only human. Right, so it can also work the other way around, okay? So in imposter syndrome, you can't see, when you're looking at somebody else, although you might, in fundamental attribution error, ascribe things to their personality, you can't see their inner uncertainties. You can't see what's going on in there. You might think they're totally with it and totally together, but they're actually maybe lacking some confidence, or there's something they'd like to say, but they're not saying it. But you can see your own inner uncertainties. So you'd be surprised, actually, how much you know, even if you're a beginner, in which case you definitely know more than you think. You know, you're just judging yourselves against the wrong benchmark, probably. You know, if you're here, you must know stuff. You're sensible enough to come here. You're not daft, right? But you may realise there's a lot still to learn. If you realise how very much you don't know and you've been doing this for longer, then quite possible that you're an expert, because there's a bit in the middle where you think you know stuff, a brief sort of, I don't know, a happy 5 minutes or something, I don't know. And then from there on, it's you just realise more and more how much there is to know, and hopefully are a bit more tolerant of other people's understanding, because you can't know it all. So you might work with people who have imposter syndrome. You might have it yourself. So do listen to them, and again, see later, basically. So if you have the opportunity, if you're suffering from imposter syndrome, also try and look at yourself from the outside view. What would somebody else know? I did a fabulous exercise once on an IBM training course, where it's just to write a profile, kind of like selling yourself in just factually descriptive of things you did, but sort of explaining your job to somebody else from the outside without any of the, I'm only this. And not my team did this, but specifically what do you do? And that, trying to take that outside perspective can be really useful. Or get somebody else to write it for you, even, if you'd like to ask them. So, there we are, looking at each other, judging each other. Perhaps we ought to actually talk to each other. So, I said back there, humaning's really important. Understanding how people function, that they're getting by extraordinarily well within the constraints of 1.4 kilos of jelly, is helpful. It's, we are only human. So that's going to help you a little bit in getting on well with them. But we do need to actually communicate with them to successfully build and deliver a system. We're not back in the 1970 pipeline where it just passes on to the next person. Things are happening synchronously now. We're building bigger, more complex systems. We're delivering them faster. There's a lot going on. You can't do that in a bubble. So I would like some more volunteers, because wise people have said many a time, and including at this conference this week, that thinking time is a lot longer than typing time in software development. So there's a lot of gathering of information to reason about and picking out the essence of that to inform what you do from the big picture. So here's the big picture with Where's Wally. All I need is a few volunteers to find Wally. Or if you've got any Marvel fans, where's Spidey? So I'm not going to make you do it up here. You can take the book away. Please come and find Wally. Hang on, let's give you a... There you go. Find Wally on that one. Spidey or Wally?
Wally, please.
Spidey. Not Spidey. There you go. Spidey, there you go. So, thank you. And two more to find Wally, please. I think let's... Yeah. And... Oh, you're fighting for it. There you go. Right, so you can ignore me for a bit and just go find Wally, okay? Right, so while they're doing that, let's talk about communication. So bees are fantastic at communication. It's not very complicated and versatile in the different things they can do, but it's unambiguous. And this is why we have programming languages as well, right? You want something that's unambiguous. Natural language doesn't quite hack it. There are all sorts of confusions that we get for that. It's worse in some languages than others. So this is how bees do it with their pattern of dance to tell the other bees where the good sources are to go to. Humans, entirely different, right? You're going from one individual's thoughts, abstracted into language. Transmission is not usually too bad unless you're in a noisy space. It gets transmitted fairly accurately, but then it goes into somebody else's ears. As we've seen already, senses are not equivalent to data. Those senses get processed, and when you're processing that, what you hear, that's driven by what you already know, your experience, your mood, all sorts of factors. So it's imperfect encoding of thoughts, and it's the imperfect decoding on a different system as well. So it's not going to be perfect. We can't do this. We can't mind meld. We can't share our thoughts directly. It's always going through the medium of language into which one person has to encode and the next person decodes. So we're pretty good at parsing grammar. No problem at all with grammar. So this meaningless sentence, created by Noam Chomsky, colourless green ideas sleep furiously. So you can see it's grammatically correct, right? It's got adjectives and verbs and adverbs in all the right places. If any of those made any sense, you'd be able to work with it. But does it make sense? No, we can't have no idea of the meaning because the semantics are just not there, right? So I'm going to quote Jez again, and again, common advice. Giving it a name tells you why. It gives some meaning to it that'll be meaning to others. And it's hard to think of names, I know. And thinking of names that will be clear from somebody else's perspective, even harder, because you're immersed in your Where's Wally world, and they may be meaningful to you, but to somebody else looking just at Wally, they're not going to necessarily make sense. So it's not obvious. A name is not obvious unless you've run it by somebody else. You cannot say it's obvious unless you've shown it to someone else and says, what does this represent? And they go, oh yeah, it's obvious. So you need to talk to people. Recognize that it's not going to necessarily be obvious. So when you're writing code, You're doing the distilling of all that knowledge that you've got in that big Where's Wally picture. You can see all of that. You're taking the relevant elements of that, distilling it down just to, okay, here's Wally. So when you're doing some changes to code, you've got basically just Wally, that thing that it all distilled down to. And to make sense of that, get enough meaning from it to do something useful with it, you need to reconstruct some of that. So things that will help you do that, maybe documents, there may be comments, definitely identifies if they are actually genuinely meaningful to others. Tests can do that, executable documentation if they're done right. And other things such as other kinds of automation even, because again, that's executable documentation of how the system is put together. So, communications, though, isn't just via code. We also function in groups. It's part of the process of creating a big system, the sort of systems we have these days. It's a group of people doing it. So, here we are, Maslow's hierarchy of needs, updated for the 21st century. And you'll notice some of the higher things in that are about groups. So belonging is about friends and family, belonging like that. And higher up again, self-esteem is about recognition and respect. Again, that's about your peers. It's not about people around you. It's not about you as an individual. So let's bear that one in mind. And let's talk about, we'll come back to that one. Let's talk about Bay of Pigs. Anyone familiar with the Bay of Pigs story? Yeah, absolutely. So for those who aren't, short version, a failed US invasion of Cuba in 1961, generally considered to have been quite a bad idea. So one of the reasons mooted for this one is that groupthink took over here, had a homogeneous group, lots of very similar people with a charismatic leader in JFK, and they either agreed with the leader or they didn't dare express dissent. So, some of the characteristics of groupthink, there's that illusion of invulnerability, being over-optimistic, powerful people, nothing's ever gone wrong for them, you think it's going to be okay. If the team works well together, that can also be part of the problem, because there's some overconfidence in how well they can handle things. I've mentioned that leadership bias. If you've got a leader with strong views of their own on the subject, that's going to tend to lead things towards that view. They may, back to that Cassandra, right, dismissing warnings. A group like this may be very quick to dismiss any challenges to their assumptions, their confidence in how great they are as a team at making the right decisions. So that, yeah, let's have a canary, not a Cassandra, basically. Stereotyping can be bad in this as well. Again, that's about attributions and saying if you're dissenting, well, you're stupid, you're wrong, you're weak, or you're weak is going to go, I can see you being an important one in this one, right? Or disloyal. And on the other side, if you're not saying anything, that's the illusion of unanimity, taking people's silence to mean they agree. Whereas actually they might be sitting there thinking, God, how do I say that JFK is wrong? Broad. I mean, they probably didn't put it quite like that, but they're very powerful things that stop people speaking and communicating in groups. So, just a few suggestions on things that might be useful with that. Some useful phrases. What problem are you trying to solve is a really useful one to ask in almost any circumstances, actually, of what is it we're actually trying to get to, rather than getting carried away with the ideas, like, for example, the new wiki or there was no problem we was trying to solve there. So what? If you come up with an idea, like we could do this, okay, and if we do that, so what? How does that move us towards solving that problem? It's it sounds contentious. I don't mean it as a contentious thing, but so what? What's the point? How is this relevant? Is it salient? Is it something we should be paying attention to? But it makes that explicit and it makes it conscious. So, do speak. I know it's not easy, but there is no such thing as a stupid question. And depending on the circumstances, you have perhaps a professional responsibility to speak up and say your part. It may not be listened to, but at least you've said it. And in some cases, it extends to a social responsibility. So thinking maybe of the Volkswagen case, I have no idea if anybody spoke up and said, should we really be doing this? But yeah, I kind of wish they had and that they'd been listened to. So, back to Maslow's hierarchy of needs, and you'll notice safety is on there, and that comes below those other higher things. And including in this psychological safety, it makes it easier to speak up if you feel in a safe place where you're not going to be put down as weak or disloyal or stupid for saying something. And if you're not the person who's trying to get a word in, make sure you listen. You can help the listening by listening and not shooting people down, but also encouraging uninterrupted contributions from everyone. And post-its can be quite useful for this, so people actually stick down their ideas and they all go on the wall. But quite often, if somebody does manage to get a word in, then somebody else very vocal will leap in and shut them down and they don't get heard. So do help the listening to happen. And right, one last theory related to belonging, and very much one I've observed in the wild in software development. You will recognize some of these. So, social identity is a theory developed by Tajfel, I think, originally, 1970. Anyway, interesting fact, I hope. A key experiment, very famous experiment in that, was actually conducted near here in with boys at a state school somewhere in the suburbs of Bristol. I couldn't find anything more precise than that, which is kind of good because he shouldn't really be revealing that information about where he did the studies. So, 1970. Little aside and a little bit of technology for you. For the young people, this is basically a keyboard and printer in one. No monitor, no processor, or any memory, but yeah, built-in keyboard and printer. So this was in the 1970 paper that I was checking up on for Tajfel. Anyway, what he did was show a bunch of slides to the boys. And they were pictures by Klee and pictures by Kandinsky, but they were not labeled as such. And then he divided the boys into two groups. This was actually arbitrary, randomized in some way, probably. And he told them that they'd been grouped according to a preference for Klee or a preference for Kandinsky, right? So we've got, this side of the room Klee, this side of the room Kandinsky. Who knows what your preferences are? Doesn't matter. So it's a minimal difference, right? A very tiny difference on just an aesthetic preference that isn't actually even true. And then he gave them a task to assign tokens to the other boys in the experiment. And what he found was that they would maximize the difference between the groups over profit. So rather than overall profit and you're getting most, so you Klee lot over here would make sure you differentiate yourself from the Kandinsky lot over here by awarding yourselves more than them, even if the rules of that come at the cost of you getting less overall. You just want to beat them rather than be equal with them, and vice versa. And there's some really quite scary other studies, a boys' camp study, for example, which built on these minimal differences, which I had to stop because it just got far too tense. But anyway, that's the experiments on it, and this is the kind of thing we get from it. Some supposed difference, a minimal difference, particularly so with the disadvantaged group as well, because they will tend to demonize the out group to just sort of build up their self-esteem a bit. So these could be identical, but framing the others in terms of in-group or out-group. So let's look at some examples we might have seen. Minimal difference, right? Who gives a damn which editor you use, so long as it's a powerful one? It's reminded me of one of my early ACCUs in Oxford. There was a boat race, and to my everlasting sadness, Emacs won. Here's another one, observed in the wild only this week in my early careers day. Hands up for Macs. Okay, and for PCs. Yeah, see? Right. How about this one? There is only one right answer to that one, I tell you. Right, okay. So anyway, minimal differences, right? Maybe not too serious, and there's something we joke about as well, but they illustrate just how easily we can divide into camps. And I once worked on a project where there were Java people and C++ people. And oh my goodness, and that also led to some very unpleasant comments. The Java people saying they weren't going to nursemaid the C++ people by teaching them how to do the Java stuff. So thank you very much, we'll do the Java and you C++ lot can stay over there. That was a very unpleasant project. So yeah, that one sounds like a minimal difference really, 2 different languages, but actually was positively toxic. So those differences don't really matter. We have an overall common goal. We have a professional responsibility to deliver some business value. That's our job, right? Or business value, or whatever the equivalent is. So we need to maintain that aim. This is not how we are. We haven't got a chip in there, thank goodness for it. We all have our individuality, our humanity. That's not a weakness. Let's embrace that. So I hope you found this interesting. An interesting introduction into psychology. Some ways it might explain some of the things you've experienced. But if not, I'm only human after all. Don't put the blame on me. Thank you.
Thanks very much indeed, Gail. Lovely talk.
I have to move so I don't get dazzled again.
Yeah. I recently read an interesting book about neuroplasticity in terms of the management, particularly in terms of pain management, chronic pain. And I just wondered, has that concept of neuroplasticity been researched in this sort of context? Because you're making statements about, this is how things function. But I'm just wondering, has there been much research in terms of particularly how people maybe can manage attention or whatever, develop extra skills and things like that?
I'm not aware of any neuroplasticity. So questions about studies of neuroplasticity. That's a hard one to say after an hour of keynote. Not that I'm aware of. It tends to look at the studies I'm aware of look at recovery of function. So, for example, if one area of the 1.4 kilos of jelly is damaged, there can be some recovery because the brain can reconfigure to some degree.
Okay, thank you.
More questions?
Was there another one over there somewhere? Okay, and if you dropped in a card and I didn't have time to comment on that one, do ask me and I'll give you my thoughts on the scenario that you mentioned.
Okay, then thanks again, Kate.
My pleasure. Thank you.